Take it, Ms. Chuka.
Thank you, Peter. Welcome everybody to I believe this is our 6th session. So if you are, like Mr. Peter said, if you are in 1324, please follow the link to go to that room. And 1314 students, you can remain in this room. And at any time, if you have any questions, feel free to speak up or put it in the chat, and Mr. Carizales and I will be happy to answer that. Okay, so I'm going to just start off by just asking this question. In the chat, if you would like to, type anything you know about this graph or this polynomial. What is anything that you can tell me about this graph? Let's see. Okay. So, and if you're not too sure, then hopefully before the session is over, you'll be able to identify some of these things, right? So Ms. Guerrero says that there are some zeros. Rachel says that there's 2 zeros, and so I'm going to just circle these really quick for you. So we have one here and one here. Okay, and we can go into details about this graph, right? If you notice at 0, 0, the graph is touching and turning, and at 2, the graph is crossing. And then we can also go into the behavior of this polynomial. So today, we'll be touching on some of those ideas. And so basically, most of the session today will be over 2.5, which is how do we find these zeros? Okay, so just a little background information. As I mentioned before, the zeros are the places where the graph is going to cross your x-axis. And so I'm circling them here. Okay, and we also know that at the zeros, the graph is either crossing through the 0 or it's touching and turning around. So for example, in this 0 here, the graph touches, but then it turns back down. And at this point here, the graph is crossing right through that 0. And so later on, we'll talk about that as well. Okay, so for this section, in order for us to actually find the zeros, we want to know, well, how many zeros should a polynomial have? And so this fundamental theorem of algebra kind of helps us to understand how many zeros a polynomial will have. And so what it tells us here is an nth degree polynomial will have exactly n zeros. Okay, and we're going to get into detail about this definition. Okay, so in this example, if we look at the definition here, an nth degree polynomial should have n zeros. Then how many zeros will this first graph have? Any guesses? 3. So that is correct. So we're going to have 3 zeros. What about the second one? 6, right? So even though these are not in order, we know that the largest degree or the largest exponent determines how many zeros we're going to have. So here we're going to have 6 zeros. Okay, great. And I guess I forgot I had done that, so let me keep going. Okay, so this next slide is something that we did last week. And so I'm just going to kind of review it really quick, and then we want to get into polynomials that have a degree higher than 2. Anytime you want to find a zero, the first thing you want to do is you want to make sure that you set your polynomial equal to 0. So here I let f of x equal to 0, and then I solve for x. So I added 2 and I get x equals 2. Here I have a quadratic function. My first step again is let f of x equal to 0. And since this is quadratic, you have options, right? You can use a quadratic formula, you can factor. Any of those methods will work. So in this example, I went ahead and factored. Now that I have my 2 factors, I can set each one equal to 0. And so I get 2 zeros, x equals 3 and x equals 3. Even though these repeat, right? These are repeating. They're the same 0. We still count them as part of the overall number of zeros. So we say we have 1, 2 zeros. Okay. And then the third one, this is already broken up into factors, as you can see here. So I can set my x equal to 0, x minus 2y is equal to 0, and x plus 2y is equal to 0. So for the first one, that's going to be 0. The second one would be if I add 2y on both sides, then I get x equals 2i. And if I subtract 2i, I get x equals negative 2i. So the graphs for these look something like this, right? So you have your 1, 0 here. And then you have your 0 here was at 3. And notice that since you had 2 3's, the multiplicity is going to tell you that it touches here, which I'll talk about a little bit later. And then here we see 1, 0. But what about these? Okay, these are imaginary zeros, so they're not going to be on that x-axis. Okay, so last week we talked about synthetic division, and we said that it can help us to find a zero. So in this example, they tell us find the zeros of the polynomial function given that x is equal to 4. So they already tell me that x is equal to 4 is a 0. That means that if we did synthetic division, as I did here, then at the end, we're going to end up with a 0 down here, which is going to make us happy. Okay. Since we have a 0 here, we can use the quotient. And so my quotient is here, which is what we covered last week, right? So we go 1 degree less. So we have x squared minus 4. So we have x squared minus 4x plus 3 is what we get as our quotient. And then we said we take our quotient, we set it equal to 0. Notice that the quotient is quadratic, so I'm going to go ahead and factor here. And then I set my two factors equal to 0. So my two zeros are x equals 3 and x equals 1. And so my 3 zeros are going to be these right here. But notice that at the beginning, they had already told me that x is equal to 4 was a 0. And so that's why I was able to do the synthetic division. So I have a question for you guys. What is the difference between this example here, find the zeros of the polynomial function, and this example that was in the next page or the page before? So this example here, find the zeros of polynomial function given that x equals 4 is a 0. Here's your function. And this example here. What is missing from this? Okay, so there's no squares, so that's true. And I had to put a 0. Any other things that are missing from this example and this example? Okay, they already gave us the first 0, right? So here they telling me that x is equal to 4 is a 0. But in the second example that we're going to work out, they have no idea, like they didn't tell me what one of the zeros were. So how can I start? Well, we could just pick any number in the world and begin doing synthetic division. But if we did that, how many numbers exist? It's an infinite amount of numbers. So we need something to narrow our choices down. Excuse me. And that's where the possible rational zero theorem comes in. And some books call it the possible rational zero test, and some call it a theorem. So either way, it's the same. Our textbook calls it a test. So to do this, we're going to take the factors of the constant term. And remember that your constant term is that last number that doesn't have a variable attached to it. And then the leading coefficient is always going to be the number in front of the variable with the highest degree. And we're going to divide those factors. And what that's going to do is it's going to give us a starting list of possible zeros that we can use synthetic division to find an actual zero. Okay, that way we're not just guessing and checking since there's infinite amount of numbers. So what is a factor? Factors are numbers that you can multiply to get another number. So for example, if we have 8, the factors of 8 is going to be 1, 8, 2, and 4, because if I multiply 1 times 8, I get 8. 2 times 4, I get 8. If we look at 24, the numbers 1, 24, 2, 12, 3, and 8, 4, and 6. These are all considered factors of 24. Okay, so the first step in solving this equation here is to use the rational zero test. So we have to find the factors of our constant term. Remember that the constant term is -9 here, but I'm just going to look at it as 9, and I'll explain why in a little bit. So the factors of 9, what numbers give you 9? 1 times 9 and 3 times 3. So my factors would be 1, 3, and 9. And then for my leading coefficient, I have a 1 in front of my x cubed. So the factors of 1 is just going to be 1. Okay, so we're going to take those factors and divide them. So the first one would be plus or minus 1, plus or minus 3, plus or minus 9. And I'm getting these from this list here. But I am adding that plus or minus 1 because any combination would give me a -9. So for example, positive 1 times a -9 gives me -9, or -1 times a positive 9 gives me a -9. So I'm considering both the positive and negatives. And then for the 1, we put it on the bottom. To get our possible zeros, we're going to divide 1 divided by 1 is 1. 3 divided by 1 is 3. And 9 divided by 1 is 9. So these right here is your list of numbers that you want to check. And so Mr. Carizales says that WebAssign will ask you for a list. And so you want to enter as 1, -1, 3, -3, 9, and -9. Okay, now that you have this list, which number should we start with? For me, I always like to start with positive 1. And if that doesn't work, then I go to -1. And if that doesn't work, then I go to the next number. So I'm going to pick 1, and I'm going to use synthetic division. Okay, so I have an x cubed. So I use 1, and then x squared is 1. -9x, I'm going to use -9, and the constant is -9. So that should be a -9. So my answer might come out incorrect. So I'll fix it as we go. Okay, let me just put the negative in there. Okay. Oops. So then here we have bring down the 1. So 1 times 1 is 1. And we write it up here. 1 plus 1 is 2. So the next step is to multiply 1 times 2, which is going to give us -7. And 1 times -7 is going to give us -16. Okay, so is that going to make me happy? So no, right? So that tells us that x equals 1 is not going to be a 0. Okay, so any questions on that? Since 1 didn't work, then I want to try -1. Okay, and so here, and let me just make sure that I have the right, okay. So let's try -1. So I bring down the 1. So I get 1 times 1 is -1. And 1 times 1 plus -1 is 0. -1 times 0 is going to be 0. And -9 plus 0 is -9. -9 times -1 is going to be a positive what? Positive 9. But remember that I have a mistake here, right? This should be a -9. So what is -9 plus 9? We get 0. So is that going to make us happy? Oops. Yes, right? We wanted to get this negative. We wanted to get this 0 down here because that tells me that x equals 1, -1 is actually a 0. Okay. Once you have 1, 0, then everything is going to be better because we can use the quotient, sorry. So here for 1, since I had a degree of 3, since my degree was degree 3, I go 1 less. So for this 1, I'm going to write it as x squared, and this is going to be my x value, but it's a 0. And then for this negative 9 would be my constant. Okay, so we use our quotient, and so we're going to use it to solve for the rest of the zeros. So I'm going to add 9 on both sides, and I get x squared equals 9. I'm going to take the square root on both sides, and then I'm going to simplify. So I get that x equals plus or minus 3. So those are going to be my other 2 zeros. How many zeros should I have total? 3, correct. So let's see what those zeros are. So my 3 zeros are going to be my x equals negative 1, which comes from the synthetic division, and x plus 3 and x negative 3. Okay, now something that you're going to need to be able to do later on in this section is get the factors as well. So since I have my 0 is x equals negative 1, I can find the factor if I take this negative 1 to the left side and set it equal to 0. So my factor is going to be x plus 1, and x equals negative 3. If I bring the negative 3 to the left side, then I'm going to have x plus 3. And if I bring this 3 to the left side, I'm going to have x minus 3. In a little bit, we'll be able to use these factors to do something else. Any questions on this example? Okay, so let's try another one. This is exactly from WebAssign. This problem is how it's being asked in WebAssign. It says, find the rational zeros of the polynomial function. Enter answers as comma separated list. If answer does not exist, enter D and E. Okay, and so here's your function. So the first step, use the rational zero test. So my constant is negative 1. So my factors for 1 is going to be 1. And my leading coefficient is a 2. So my factors for 2 are going to be 1 and 2. So I can write this ratio and divide them. So on the top, you always put your constant, and the denominator is always going to be your leading coefficient. So I'm going to have plus or minus 1, and then plus or minus 1. Okay, so to get your possible zeros from here, then we're going to divide these. So first, you want to ask yourself, what is 1 divided by 1? So I get a 1, right? And then you're going to ask yourself, what is 1 divided by 2? And that's how I get this half down here. Okay, so you want to divide the numerator by everything in the denominator. So first I did the 1s, and then I'm going to do the 2. Okay, so this is going to be my possible zeros. Okay, so that means you're going to either use 1, negative 1, a half, or negative a half, and we're going to use any one of those to do synthetic division, and then hope that we get a 0. Okay, so I'm going to start with 1. So if I do the work here, I bring down the 2. 1 times 2 is 2. Add the 3 and the 2. 3 plus 2 is 5. 1 times 5 is 5. So I bring it up here. 5 plus 0 is 5. 1 times 5 is 5. Plus a negative 1 is 4. So x equals 1 is not a 0. So I need to go on to another one. So the next one is negative 1. Oops, hold on, give me a second. I don't know what my computer's doing that. Hold on. Okay, so let me just, we're going to use -1. So here we have, bring down the 2, and -1 times 2 is -2. At the 3, we get a 1. 1 times -1 gives me a -1. -1 plus 0 is -1. And -1 times -1 is +1. So then that is going to be 0. Are you guys seeing your thing purple? Because I'm seeing my thing purple. Oh, there we go. I was seeing my screen purple, but now it's okay. So here we get a 0. So is that good or is that a bad thing? So Ruben put a happy face. So that's a great thing, right? So then we go on. Now we can use the quotient. So since we had degree 3, we're going to go one less. So we're going to have 2x squared plus x minus 1. And then we're going to use any quadratic method. So you can factor if you can, or use a quadratic formula. When I try to factor, I give myself a minute. If I can't get the factors, then maybe it's not factorable. And then I try the quadratic formula. And so here it is factorable. So we get 2x minus 1 times x plus 1 equals 0. Set each factor equal to 0. And then solve for x. So here we get 2x minus 1 equals 0. I'm going to add 1 on both sides. So I get 2x equals 1 and then divide by 2. So x is equal to a half. And then on the x plus 1 equals 0, I'm going to subtract 1 and I get x equals -1. So my zeros are going to be x equals -1, which comes from the synthetic division. And then my other two zeros came from the quotient. Okay. Notice here that the -1 is repeated twice, right? You have two -1s. So we say that the multiplicity of -1 is 2. It occurs an even number of times. That's going to be important when you're trying to graph the equation. Okay. So I'm going to give you about half a minute to try to get this one started. Start with step 1. Okay. So I kind of gave you a peek there. And see if you can get your possible zeros, and then we'll work it out together. Okay, so I'll give you about a minute. Okay, so let's see if you have the possible zeros correct. So my constant here is 1, 2, and 4. And my leading coefficient is a 1. So my constant factors go in the numerator. And my leading coefficient factors go in the denominator. So if we divide, then we're going to have 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. So we're going to end up with, these are our possible rational zeros. Any questions on the first step? Okay. So we have 6 factors. Okay, go ahead and try synthetic division. And if you notice here, I did the 1 and the -1, and they didn't work. So go ahead and try 2 and 4. Okay, let me just get some water really quick. So I'll let you try 2 and -2.
So if you see 4 and -4 don't work, okay, so 4 gives us a remainder of 4, and the -4 gives us a big remainder of 132, so the -4 won't work. So Gabriela says 2 is going to work. So let's see here. Well, let me see.
I think it was like on the second one. Ruben, go back. Go ahead and continue, Ruben. I'm trying to get some water still.
Okay, no worries. Okay, so if we look at here, Gabriela, 2 did not work, right? If we go through the steps, 2 times 1 is 2. So -4 plus 2 is a -2. 2 times a -2 is a -4. 0 plus a -4 gives us -4. And 2 times a -4 gives us a -8. And the 4 with a -8 gives us a -4. So 2 is not going to work. And again, -2 does not work either. Okay, so what do we do in this situation? And one thing to also keep in mind, this is a test. So and when you test something, it could give you a positive result or a negative result, right? We can find one or we may not find one. So what do we do in this case? So what this tells us that this function does not have any real zeros. Okay, so what we're going to do is find the complex zeros. And what this means is what we studied last week, right? We're going to get imaginary answers or imaginary zeros.
Can I say something really quick, Ruben?
Yes, ma'am. Go ahead. Continue.
So the rational test will tell you if there's a rational zero, but it doesn't tell you if there's any real zeros or complex zeros, right? So if you look at my question here, is there any zeros that exist? Can it have a complex zero? So if you look at the degree is 3, right? So it might have, it could have a complex zero. And if it did, always remember that it comes in pairs. So it would either going to be 2, 4, 6, or 8, and so on. Okay, so I did graph the picture. And so if you notice here, it has how many zeros? It has 3 zeros, but the reason we couldn't find them using the rational zero test is because these zeros are irrational. In other words, it's a decimal that goes on forever, but it doesn't repeat itself. And so that's why we couldn't find it using the rational zero test. To actually find these is a whole different ball game, which our book doesn't cover, or our class will not cover. You'll see it maybe in the next class, but not for this class. So in your answer, you would just type in does not exist, because there's no rational zeros. Ruben, did you want me to continue, or did you want to continue the next one?
No, go ahead, ma'am.
Okay. So let's look at this next example. Look at this 9x to the 4th minus 9x cubed. That's pretty big, right? But not a problem. We can still work it out the same way. So your first step is always the same. Okay, find the rational zero test. And so my factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And for the leading coefficient, we get 1, 3, and 9. Okay, so if we put them together, went the wrong way, then it's going to look something like this, right? Where we put all the constant terms on the top and all the leading coefficient factors on the denominator. So how do we divide something like this? So first, you want to start with the 1. Okay, so you're going to divide everything in the numerator by 1. So let me just, so you're going to take this one, divide the 1, the 2, the 3, the 4, the 6, the 8, the 12, and the 24. Well, everything divided by 1 is just going to be itself, right? And then for the 3, you're going to say 1 divided by 3, which is 1/3. 2 divided by 3, which is 2/3. 3 divided by 3 is 1, so we don't have to write it anymore. And then 4 divided by 3 is 4/3. 6 divided by 3 is 2. And then 8 divided by 3 is 8/3. And 12 divided by 3 is 4. 24 divided by 3 is 8. Okay. And then we would do the same thing with 9. 1 divided by 9 is 1/9. So 1/9. And then 2 divided by 9 is 2/9. 3 divided by 9 is actually 1/3, so you don't have to do that again, right? So you don't want to include the duplicates. And so you would have, these are all your possible zeros. So you might be thinking, wow, that's a lot of them. Yes, it's a lot of them, but it's better than trying infinite amount of them, right? So again, I always start with 1. So let's start with 1. Is there any questions on how we're dividing by this 1, 3, and 9? So again, you want to take the numerator and divide everything by each of those numbers. Okay, so let's use synthetic division with 1. And to save us time, I kind of did it already. That way we don't have to, spend a lot of time on that. And as you can see, 1 didn't work. So let's see what the next one is. 2. So let's try number 2. Okay, so I bring down the 9. Negative 2 times 9 is negative 18, plus negative 9 is negative 27. Negative 2 times negative 27 is positive 54, plus negative 58 gives me a negative 4. Negative 2 times negative 4 is a positive 8, plus 4 is 12. 12 times negative 2 is negative 24, which is going to be 0. So yes, we don't have to go looking for others, right? So x equals negative 2 is a 0. So now we get our quotient. What happened here? Can I go use the quadratic formula, or can I factor this already? You could try to factor by grouping. Maybe that would work, right? But if you're not sure on the grouping, or you don't feel comfortable with grouping, then what you can do is you can just start the process all over again. Okay, so let me go back really quick. So this is our quotient that I have on this slide. So we just start the process again. So my possible zeros, I'm going to use 3. You can use anything. You could have started with 1 again. But to save us time, I'm going to use 3. We go down. 9 times 3 is 27. Plus negative 27 is 0. Times 3 is 0. Negative 4 plus 0 is negative 4. Times 3 is negative 12. So 3 is a 0. So that's great. So you want to kind of keep doing this until you end up with a quotient that is quadratic, because when it's quadratic, then we have different methods that make it easier to solve, like the quadratic formula, the square root property, factoring, and so on. So my 9, since I started with a cube here, then this 9 would be 9x squared. I don't have an x, and then I have a minus 4. So I'm going to add 4 on both sides and take this divide by 9. So I divided 9 here and 9 here, and I can take the square root. The square root of 4 is 2. The square root of 9 is 3. And you can rewrite this as square root of 4 divided by square root of 9. And that's going to give you x equals plus or minus 2/3. Okay. So let's bring everything back together. So first synthetic division told me that x equals negative 2 was a 0. The second synthetic division told me that 3 was a 0. And the quotient told me that x equals plus or minus 2/3 were zeros. So here are all my zeros listed together. So I have 4 of them. And the factors are going to be x plus 2. So remember, bring the negative over to the left side, x plus 2, x minus 3, x minus 2/3, x plus 2/3. Okay, any questions on that? So again, at this point here, let me just go back really quick. So at this point here, you can either check to see if you can factor by grouping. If you can't, then you can continue on with a new round of synthetic division. Sometimes you can factor by grouping, and sometimes you can't. So synthetic division would be the only case that we have. Okay. So here is another example. Actually, we already did this one, right? X cubed plus x squared minus 9x minus 9. If you remember, that was one of the first examples I had today. But then I have it here is because this is another question from WebAssign, where they're going to give you a polynomial and they want you to list the zeros, possible zeros. They want you to list all the real zeros, and then they want you to graph it. Okay. So as a reminder of what we got for x cubed plus x squared minus 9x minus 9, I wrote it on the next page. So remember earlier, the possible rational zeros were 1, 3, and 9. And when we did synthetic division, we got 0. So x equals 1 should be a 0 here. And then we got our plus 3 and our minus 3 were zeros. Okay. So we have list all the possible zeros. So here's all my zeros. List all the real zeros. And what I want to focus on is letter C, sketch the graph. Okay. When you want to sketch a graph, there's some things you want to remember from section 2.2. What is the end behavior of the graph? What is the multiplicity of each zero? And does the graph touch or does it cross? And then you want to find your zeros and the y-intercept. And then number 5 is to list other possible points. Okay, so I'm going to focus on this part of the problem. So just a refresher from 2.2, the end behavior. When you went through that section, you probably saw a whole bunch of definitions. And what I like to tell my class is, if you remember what x squared looks like, if you remember what negative x squared looks like, x cubed and negative x cubed, you'll never forget the end behavior or the multiplicity, whether a graph touches or crosses. Why? We know that the graph for x squared is this parabola. The graph for negative x squared is upside down, and then we have the cube and the negative x cubed. So to find the end behavior, you're looking at the leading coefficient and the degree. Okay, so like here, my leading coefficient is a 1, and my degree is even. Okay, leading coefficient is negative, the degree is even. Leading coefficient is positive, the degree is odd, and leading coefficient is negative, degree is odd. Okay, so whenever you're in this situation where you have a degree that is even with a positive leading coefficient, your graph always rises right and rises left. As you can see here, it's going up and it's going up. You guys can see my pointer, right? Because I'm pointing, but I was just thinking maybe you can't see my pointer. Okay, great. And then if you have a negative leading coefficient and an even degree, it's going to fall down on the right, fall down on the left, and so on. So which behavior will our function have? So which, notice here we have an odd exponent or leading odd degree with a positive leading coefficient. So is it going to be, let me write some letters for you here. Is it going to be like A, B, C, or D? It's going to be more like C, right? Because it has an odd and it's positive, so it's going to act this way. Okay, so our behavior for our graph is going to be that it rises right and falls left. So the graph will rise right and fall left. So now for the multiplicity. If you remember x squared, notice that the graph is touching here. It touches a 0, then it goes up. So we say it touches and it turns. But let's see why. If you solve for the 0, this is one way to solve for it. Take the square root on both sides. Another way to do this is to write it as x equals 0, x equals 0. So you have two zeros, right? Okay, so if you have an even multiplicity, if it occurs 2, 4, 6, and so on, the graph is going to touch and it's going to turn. Okay. And if you look at the x cube, then you're going to have, if it repeats, if you have something that repeats an odd number of times, then your graph is going to cross. Okay, so let's look at ours here. So these are my zeros. Let me see really quick. So if you notice, our zeros are x equals -3, x equals -1, and x equals 3. So none of them repeated, so they're all just going to cross. Okay. Any questions on when it repeats? I mean, when it touches or crosses? Okay, then we want to look at the y-intercept. So to find the y-intercept, then you let x equals 0, plug it in, right? So plug in 0 for all your x's, and we get -9. Then the last step is to pick additional points. Okay, so first thing, plot your zeros. Oh, my picture didn't come up for this one, but I can draw it here really quick. Give me a second. Okay, so my zeros were, Ruben, do you remember what they were? I can go back and look. So I think we had a negative, that was the y-intercept, right? Okay. Actually, let me share my screen because every time that I switch, I'm gonna have to redo it. So let me share my screen really quick just to make it better or faster. Let me open the PowerPoint and I'm share the screen. Okay, so oops, let me just, can you guys see my screen? Is that a yes, Ruben? I can't see the chat no more.
Yes.
Okay, so you plot your zeros, and so I did that. They are right there in green. Okay, so then our next step is going to be to apply the end behavior, and you want to plot your end behavior at each of your, at the farthest zero on the right side and your farthest zero on the left side. Okay, so if you look at my picture here, at x equals 3, we said that the graph was going to rise, right? And so that's why I have the arrow going up right here. And then on the x equals -3, we said that the graph is going to fall to the left. So that's why I put my graph falling to the left here. Okay. On WebAssign, most of the time they just give you a graph to choose from, but those are the things that you would want to be looking at. Okay, so the next one, plot the y-intercept. So I plot my y-intercept down here in the green at -9. Okay. When I use my mouse, can you see me moving my mouse, Ruben?
Yes, ma'am.
All right. So your last step is plot additional points. So it's important, what additional points could we plug in? You want to make sure that you plug in points between the zeros. So for example, I have a 0 here and I have a 0 here. So I have a gap here. This is x equals -2. And notice that on this 0, I made my blue line go up past that 0 because it's going to cross there, right? And it's crossing over here. So I'm going to use x equals 2, negative 2. On the left side here, I plug it in, x equals negative 2. So everywhere you see a negative 2, you're going to, an x, you're going to substitute negative 2, and we get 5. Okay? So I represented that with this red dot up here, negative 2 and 5, right here. And then I want to do the same. So between this 0, x equals negative 1, and x equals 3, I have 2 points. You can choose one, but I like to pick both so I can know exactly what's going on with my graph. So when I plug in a 1 here, then I get negative 16. So I represented it by this dot at the very bottom. And then at 2, I get negative 15. So I know that it's going to come back up. So now I can connect my dots. Okay, so now I'm going to draw my graph. And of course, they call this sketching a graph, right? Because it's not going to be all pretty if you sketch it. Well, maybe yours is, but for me, my writing isn't that great. But I went ahead and showed you an actual picture of what the graph looks like on the next page. So this is what the graph looks like here. Okay. But you can see here that we end up with the same graph. Okay, you just can't see the bottom part of it because of the domain. I don't have it wide, small enough to show you the whole graph. Okay, so any questions on that? So again, it's important that when you're gonna graph, you need to, number 1, what is your end behavior? Number 2, do your zeros, do they touch or they cross? Number 3, plot your zeros, find the y-intercept, and then pick additional points. So let's go on to the next one. Find a polynomial function with real coefficients that has the given zeros. So we have a 3 and a negative 4, and they want us to find a polynomial function. So what does that even mean? Okay, so I gave you kind of a picture here. All this time, our goal was to find a quotient, and then we did some work here, right? We either factored or we used the quadratic formula, and then we got our answer. But now they're giving us those zeros. And so your goal is to end up with something that looks like this. Okay, so we're kind of working backwards. Okay, so let me go back to the blackboard. That way I can see we have 10 minutes. So let me just get the slide back. I don't have no more drawings, so. So again, yeah, we're gonna work backwards and find the actual equation. So the first thing is gonna be, I'm still getting to that page, okay? So I'm talking, but I'm not sharing anything yet. So we are gonna get to that. All right, let me just share. Okay. So the next step is to list the factors. So our factors is going to be x minus 3 at the negative 4, y to the left side, x plus 4y. Then we have x minus 4y. Then you want to put your function f of x is equal to some number. We don't know what that number is. And then you're going to list your 3 factors. Okay. So if we multiply, I always encourage you to start with your imaginary factors. So here I'm going to have x times x is x squared. X times negative 4i is negative 4ix. 4ix is 4ix, and then 4 times negative 4, negative 16i squared. Notice the negative 4ix and the 4ix cancel, or it becomes 0. And so I'm left with negative 16i squared. What can I do with this I squared? I can replace it with a negative 1. Okay. So negative 16 times negative 1 is a positive 16. And so now we have x minus 3 and x squared plus 16. Multiply those together. Okay, so we're going to have x times x squared, which gives us x cubed. And then x times 16 gives me 16x, negative 3x squared, and negative 48. Ruben, you want to continue this part really quick?
Yes, ma'am. Okay. All right. So we are here. We have x cubed plus 16x minus 3x squared minus 48. Okay. All right. So what we want to do is we also want to put it in order just to make sure that we have the right polynomial. So we have x cubed minus 3x squared plus 16x minus 48. Okay. All right. Now, what we're going to do is we can use 1 because 1 is going to give us this polynomial, x cubed minus 3x squared plus 16x minus 48. Okay.
And just for this purpose of this example, in WebAssign, if you put a 2 or a 3 or a 4 in place of 1, your answer would be correct once you multiply it out, because it's still going to give you the same zeros. So I always just use a 1, and then that would be your answer in red. But the next example, they actually are more specific. Go ahead, Ruben.
Yeah, so we'll go ahead and cover that, okay? All right, any questions so far? All right, so kind of go really quick just because we want to finish this last example. We got 7 minutes. So on this one is also straight from WebAssign, and they're going to ask you this question. Find the polynomial function f with real coefficients that have the given degree, zeros, and the solution point. So you saw that given the zeros, we can find the polynomial, and what Ms. Chuka was able to do was use the linear factorization theorem to go ahead and give any solution. Again, she just chose one to give an example, but this is where we're going to be more specific. With this solution point, we're going to be able to choose a particular a sub n in order for us to satisfy these conditions. Now, again, the point that you want to also keep in mind is that they want a degree 4, okay? That means that our polynomial, the highest exponent, is going to be a 4, okay? So we're going to do it the same way. We're going to use these zeros to get our factors, okay? So our factors for -4 are x plus 4. The factor for 1 is going to be x minus 1. And again, as our last class, I is our imaginary number. That one came from the square root of the -1, right? So so x of I, we're going to have x minus I, and the negative I is going to give us the x plus I. So again, we're using the linear factorization theorem to go ahead and get our polynomial. So we have a sub n, which we don't know yet, multiplied by x plus 4 times x minus 1 times x minus I times x plus I. Now, I like to do the real part first, and then I like to do the multiplication, and then I combine, okay? But it's up to you how you want to do. You can do it just straightforward. So on our example here, we did the imaginaries first. So x times x gave me the x squared. The x times the I gave me the ix. Then now the negative I term, negative I times x gives me the negative ix, and the negative I times the positive I gives me the negative I squared. Okay, all right. And then combine these terms here. So the xi, the ix, excuse me, and the negative ix become 0. They cancel each other out. Okay, excellent. And this gives us x squared minus I squared. All right, now let's look at the x plus 4, x minus 1. Let's go ahead and FOIL that one out too. But before we did that, again, we validated what I squared was, which is a -1, which is going to give us x squared plus 1. Okay, all right. So we continue with the x minus 1 multiplied with the x squared plus 1. So x times x squared is the x cubed. X times the 1 is the x. Now the -1. -1 times x squared is negative x squared. -1 times a positive 1 is going to give us a -1. Awesome. Okay? All right. Now the last term, the x plus 4. When we multiply the x plus 4, we're going to get this long equation. So x to the 4th plus x squared minus x cubed minus x plus 4x cubed plus 4x minus 4x squared minus 4. Okay, and what we want to do next is we want to combine our like terms. We want to put all our terms that are the same together. Okay, and it's going to give us this. Now, one thing you should notice, we have what we wanted. We have a polynomial of degree 4. That's what the problem has suggested. But now we need to find what is a sub n? What is this going to, how are we going to get this value? So now that's where we're going to use the solution point. And the problem says that when I plug in 0 to this polynomial, the answer should be -8. So that's what I'm going to do. I'm going to put into this polynomial the value of 0 for x and set this polynomial equal to -8. Okay? All right. So when I do this, again, I have 0 to the 4th, 0 cubed, 0 squared, and then the 0. So 0 to the 4th is 0, 0 cubed is 0, 0 times 3 is 0, 0 squared is 0, 0 times a -3 is 0, and 3 times 0 is 0. So the only thing that I have left over is the -4. So to solve for a sub n, I'm going to divide both sides by -4. So this is going to give me a sub n is equal to 2. And voila, I'm able to find my polynomial. My answer is for a sub n is 2. But what I have to do now is distribute this 2 to my polynomial inside. And it's going to give me 2 times the x to the 4th is 2x to the 4. 2 times 3 is 6x cubed. 2 times a -3 is a -6x squared. 2 times a +3 is a 6x. And 2 times a -4 is a -8. And we've done it. With this zeros and the solution point, we're able to get the specific polynomial that satisfies these conditions. And again, we came up with a degree 4, and we had a degree 4. Any questions? And we have a minute left. Anybody have any questions? Awesome. Yvette, do you have any last words?
That's so for next week, we will be covering um, it's kind of a review of all of chapter 2. So some of the things that we didn't talk about, then for example, some questions from 2.6, we'll be able to review next week. Some stuff from 2.2 that we didn't cover will be there. But if you have like particular things that you would like to see from 2.6, you can email me and I can make sure to include it in our review. So my email, I don't know why it's not letting me type my email. I put ichuka here at epcc.edu, but it doesn't let me send it as a chat. Oh, there it is. So if you have any particular questions that you would want to see, you can send me an email and say, can you include how to find the asymptote or how to find the oblique asymptote or any of that. We'll make sure to include it in the review. And then also, we do have our tutors available here in this room. And so if you have a particular question, whether it's from today's session or from a different section, they're more than happy to stay here and help you in a one-to-one situation. And so I encourage you all to use our tutors, and also please make sure you sign in if you haven't yet. Any feedback is great, and then I will be sending this out to your instructors. That way, those of the instructors that are giving you extra credit, they can do that, or if it's an assignment, they can do that as well. But if there are any questions? So hopefully everybody is able to find their zeros, right? And we're excited to be able to be here every week and help you guys.
Okay, thank you, Mr. Carrizales. Thank you, Ms. Chuka, for today's presentation. And remember, guys, to sign in the link that Ms. Chuka gave you. And also remember that these sessions are recorded and you'd be able to review them at another time when you need to. I'll be stopping the recording now.